double slit experiment. S two slits and screen. Take monochromatic source of light S. Monochromatic source, blue light, yellow light, एक वेवलेंथ की लाइट, टू स्लिट्स S1 and S2 at equal distance from source. And screen as shown. It was found on screen maximas and minimas. This is maxima, this one minima, maxima, minima, minima, maxima, minima, maxima. It was found on screen, maximas and minimas. This is maxima, this is minima, maxima, minima, maxima. Right? Here, maxima, minima. This means it is redistribution of energy, bright, dark, redistribution, so interference. This means light is superposing from two coherent sources, that is S1 and S2. ये वेव फ्रंट हो गया, यहाँ वेव फ्रंट, ये फोटोन हो गए, ये डिपेंडेंट सोर्सेज हो गए. सो दीज आर कोहेरेंट सोर्सेज. तो व्हेन लाइट सुपरपोज ऑन स्क्रीन देयर विल बी इंटरफेरेंस फ्रिंजेस. Suppose this is observation point. This is one ray, this is another ray. This is center of screen. That is, there are interference fringes. Width of fringes. This is bright fringe, dark fringe, bright fringe. इस इनके बीच का डिफरेंस डिस्टेंस में विड्थ ऑफ डार्क, दो डार्क के बीच का डिस्टेंस विड्थ ऑफ ब्राइट फ्रिंज. नाउ विड्थ ऑफ फ्रिंजेस, this is capital D, this is small d, this is point L, this is a point M, this distance say x. Let O is center of screen, P is observation point, and OP is x. Capital D, distance between slits and screen. Slits means coherent sources. Small d, distance between two slits or distance between coherent sources. This distance will be d by 2. This distance will d by 2. Now, path difference will be S1P minus S2P. This is the length of one wave, this is the length of second wave at observation point. So, path difference at observation point will be S1P, S2P. Now, S1P whole square, it is S1M whole square plus MP whole square, S1M whole square, D square, MP. This is MP. This was x plus d by 2. It is x plus d by 2 whole square. It is d square plus x square plus d square by 4 plus xd. And S2P square. This is a right angle again. So it is S2L whole square plus LP square. So it is D square. This is x minus d by 2. Why? This is x. This one is subtracted. Then it will be LP square. Or it is d square plus x square d square by 4 minus xd. Path difference S1P minus S2P, ये चाहिए हमें. S1P whole square minus S2P whole square. This d will cancel with this d, x square d square by 4. It will be 2xd. path difference was S1P minus S2P. S1P minus S2P, S1P plus S2P is 2XD, or S1P minus S2P 2XD, S1P plus S2P, or this is path difference 2XD. This S1P, the screen is very small, 1 or 2 centimeter wide. So this S1P nearly equal to capital D, S2P also. So it is D plus D, or path difference XD by capital D. Number first. Maxima. For maxima, path difference n lambda it was condition for maxima from mathematical treatment, where n is 0, 1, 2, so on, or x n lambda capital D by small d. Third, where what is x? Distance of bright fringes from center of screen. X was OP. O center of screen, P observation point. So X was distance here maxima to bright fringes. X0, N0. Central bright fringe X1, first bright fringe N1, X2, X3, N is 0, 1, 2 for central fringe, for first bright fringe, second bright fringe, third bright fringe. This distance is central fringe. कहाँ है वो? सेंटर पर है, कोई डिस्टेंस नहीं है. फिर फर्स्ट ब्राइट, सेकंड. अब दो का डिफरेंस लेंगे तो क्या आएगा? दो मैक्सिमास का. Hence width of dark fringes. दो मैक्सिमास का डिफरेंस लेंगे तो क्या आएगा? मिनिमा की विड्थ, मिनिमा. that is x1 minus x0, it is lambda d by d minus 0, it comes out to be lambda d by d, or x2 minus x1, it is 2 lambda d by d minus lambda d by d, it comes out to be again, or x3 minus x2, 3 lambda d by d minus 2 lambda d by d, again it comes out to be lambda d by d. Hence, width of all dark fringes is equal, that is beta lambda d by d. This is maxima. दो मैक्सिमास का डिफरेंस करोगे तो क्या आ जाएगा? विड्थ ऑफ डार्क. मिनिमा, for minima, path difference. What was path difference? This x d by capital D, 2n minus 1 lambda by 2, where n is 1 for first minima, 2 for second, 3 third. X 2n minus 1 lambda by 2 into capital D by small d. This is fourth and this is fifth. This x is distance of dark fringes from center of screen. X was OP, observation point का center of screen से distance. Therefore, x1, distance of first dark fringe from center, and 1, 2 minus 1, it is lambda d by 2d. x2 and 2, 4 minus 1, 3, 3 lambda d by 2d. x3, 5 lambda d by 2d, and so on. Hence, width of मिनिमा है. मिनिमा का डिफरेंस लोगे ब्राइट फ्रिंजेस, that is x2 minus x1, it is 3 lambda d by 2d, lambda d by 2d, it comes out to be lambda d by d, or x3 minus x2, it is 5 lambda d by 2d minus 3 lambda d by 2d, it is again lambda d by d. And so on. Hence, width of all dark or bright fringes is equal, that is beta lambda d by d. This was central, right side. This was intensity. This was center of screen. एक जैसी हाइट बनाओ ये n lambda, ये lambda maxima. This is 2 lambda. This is minus lambda. This is minus 2 lambda. If here you want to write, it is lambda by 2. It is 3 lambda by 2. Oh, it is 0. Lambda is 2 pi. This is 4 pi. Phase लिखो तो. This is intensity distribution diagram of interference. Angular width of interference, that is theta. It is beta upon d. Arc upon radius. The radius is capital D beta. Beta was lambda d by small d. So the angular width is lambda d. Two slits, interference arrangement such that distance between slits and screen is half the distance between slits. If this distance is 2d, then this distance is d. The CD is d. S1C, S2C, capital D. This capital D. Given this distance, half of this distance, this means this is 2D, this is D, this is D. Now path difference 2n minus 1 lambda by 2. S1P this is S1P, this is capital D minus this, again S1P it is S1 T1 whole square plus T1P whole square under the root. S1 T1, it is D square. T1P, it is D minus X whole square S2P, this is S2P, this length, it is S2T2 whole square plus T2P whole square under the root. It is D square, it is D square plus X, D plus X whole square 1 by 2, 1 by 2. Path difference S2P minus S1P. Path difference, that is, if it is 2n minus 1 lambda by 2 for minima. Here n is 1 for first order minima. Therefore, T square D minus X whole square 1 by 2 minus S2P plus D square D minus X square 1 by 2 is lambda by 2, yn is 1. D square common, so outside root it is D. 1 x by D square 1 by 2 D 1 minus x by D square 1 by 2 lambda by 2. As x is equal to D, observation point given, obtain value of D in terms of lambda such that first minima on screen falls on distance D, not on x but on D. So it is D1 plus 2 it is 1 D by D square 1 by 2 d 1 minus d by d square 1 by 2 lambda by 2. It is 4, it is 1 d, it is 5 root d, 1 minus 1 is 0, so 1 root 1 lambda by 2 or d 5 root minus 1 is lambda by 2 or d comes out to be lambda 2 5 root minus 1. Condition for sustained interference. First condition, sources coherent. Second, amplitude, two waves equal. What is effect on interference fringes in Young's experiment of following. A. There are many questions screen moved away from slits. The answer, lambda d by d is beta. As d increases, width of fringes will increase. but intensity, visibility decreases. Why? Distance of source and screen is increased. Second, source slit moves closer to double slit lane. For interference, S by S lambda by D be satisfied, where S width of source slit, capital S distance between source slit and coherent sources. Source slit is moved closer as S decreases. S by S increases. Slits, fringes, less sharp, as S by S increases, the condition S by S is violated, so fringes disappears. This is this answer of B. See, separation between two slits is increased. Now answer beta lambda d by d, as d is increased, beta of fringes decreases. This is increases, beta decreases. No effect on intensity D. Monochromatic source replaced by another monochromatic source of less wavelength. Beta lambda d by d. As lambda decreases, beta also decreases. The width of source slit is increased for fringes S by S lambda by d. As S increases, S was width of source slit, fringes becomes less sharp as S by S start increasing. When above condition violated, then fringes disappears. Monochromatic source is replaced by white light. There is no change.